Hello students, so let's do some revision by solving some problems. So this is a question from vector algebra. If A, B and C are three vectors of magnitudes 3, 4 and 5 such that each one is perpendicular to the sum of the other two vectors, then we have to prove this, that is magnitude of A plus B plus C is equal to 5 root 2. Okay. So for this, here whatever is given you have to write first. Okay. So here magnitudes of A, B and C are given. So magnitude of A, magnitude of B and magnitude of C is given. Okay. Now it is given that each one is perpendicular to the sum of the other two. That is, this A vector is perpendicular to the sum of B and C. Then B vector is perpendicular to the sum C and A. Then C perpendicular to the sum A and B. Okay. So perpendicular means what? Perpendicular means the angle between them is 90 degrees. And we know that when you take a dot product AB cos theta, cos 90 is 0. Okay. So dot product of these two vectors is 0. So okay. So you can write this as A dot B plus A dot C is 0. B dot C plus B dot A is 0. C dot A plus C dot B is 0. Okay. Now we have to prove that this magnitude is equal to 5 root 2. So whenever you are given magnitude, you have to take the square so that you can write this as dot product of A plus B plus C. Okay. So multiplying, that is taking the dot product, will get A magnitude of A square, magnitude of B square, magnitude of C square. Okay. And then this into this, that is 2 times A dot B plus B dot C plus C dot A. Okay. Now this is magnitude of A, that is 3 square plus 4 square plus 5 square. What about this? If you add these three equations, okay, what you will get? A dot B plus A dot B. So 2 times A dot B. So if you add 1, 2, 3, you will get this thing. Okay. And that is equal to 0. So you can put here 0. Okay. Here we can write adding 1, 2 and 3. Okay. This is 9 plus 16 plus 25. So then 25. So this is 50. Okay. Square is there. So root we have to write. Root of 50. So this is 25 into 2. So 5 root 2. So we proved that magnitude of A plus B plus C is equal to 5 root 2. Okay. Let's solve this. So you have to find the shortest distance between the lines. Lines are given. So this line I have to write in a simplified way. That is, this line can be written as 2 plus 2i plus 4j plus 5k plus mu 3i plus 4j plus 5k. Okay. Now these two lines are in the form a1 plus lambda b1, right? And this is a2 plus mu b2. So the shortest distance is given by formula magnitude of b1 cross b2 dot a2 minus a1 upon magnitude of b1 cross b2. Okay. So for this we have to find a2 minus a1 and b1 cross b2. So we know what is a1 and a2. These two are a1 and a2. Okay. So a2 minus a1, 2i plus 4j plus 5k minus I plus 2j plus 3k. So this is 2 minus 1, 4 minus 2, 5 minus 3. Then b1 cross b2. So you have to take the cross product. 2, 3, 4, 3, 4, 5. 3 5s are 15, 4 4s are 16. 10 minus 12, k, 8 minus 9. So this is minus I plus 2j minus k. Okay. So the shortest distance is minus I plus 2j minus k dot product I plus 2j plus 2k on magnitude of this. That is 1 plus 4 plus 1. Dot product will get minus 1 plus 4 minus 2 upon root of 6. 4 minus 3, 1. So 1 upon root 6. This is the shortest distance. Okay. Next question is, if the area of parallelogram whose diagonals are given by I minus j minus k and 2i plus lambda j plus k is root 26 by 2 units. Okay, you have to find lambda. Now here they have given diagonal. So this is a parallelogram, and if the diagonals are given, then area we find by using half into magnitude of d1 cross d2, right? If the adjacent sides are given, then use the formula a cross b, magnitude of a cross b. Okay, so here d1 and d2 are given. So d1 vector I minus j minus k and d2 2i plus lambda j plus k. Okay. So we have to find this. So we have to first calculate cross product. J, K, 1 minus 1 minus 1, 2 lambda 1. Okay. So taking the determinant, minus 1 plus lambda J, 1 plus 2 plus K lambda plus 2. Okay. So this is minus 1 plus lambda I minus 3J plus lambda plus 2K. Okay, now let's find out the magnitude, or we'll write directly. Area is given. It's equal to half magnitude of T1 cos T2. Okay. Area is root 26 by 2. Magnitude root of minus 1 plus lambda the whole square plus 3 square plus lambda plus 2 the whole square. Okay. This 2 gets cancelled and we'll square both the sides. So this is 26 equal to minus 1 plus lambda the whole square plus 9 plus lambda plus 2 the whole square. So this term I'll write this side, 1 minus 2 lambda a plus b the whole square 4 lambda plus 4 equal to 26. Okay. So lambda square 2 lambda square minus 2 lambda plus 4 lambda plus 2 lambda 10 plus 4 14. So we can take common here 2. Okay, so this 2 gets divided here, so we will get 13. Okay, so we will get a quadratic equation 7 minus 13. So minus 6. Okay, 0. So the factorization product sum is 1, 2, 3 minus 2 plus 3. So lambda minus 2 lambda plus 3 equal to 0. Okay. So lambda is equal to 2 or lambda is equal to minus 3. These are the values of lambda. Okay. Next question. If alpha, beta, gamma are the angles which a line makes with positive directions of the axis, then you have to find the value of sine square alpha, sine square beta and sine square gamma. Now when you see this, that is alpha, beta, gamma, you know that there is a relation to direction cosine. Okay. So what is that relation? We have L square plus M square plus N square is equal to 1. So direction cosines are cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay. So start with this equation. So sine square alpha plus sine square beta plus sine square gamma. Okay. We have to write this sine square in terms of cos. Okay, so using trigonometry, we can write 1 minus cos square alpha, 1 minus cos square beta, 1 minus cos square gamma. Okay, so 1 plus 1 plus 1, this will be 3 minus, then right inside, cos square beta plus cos square gamma. Okay, this value is 1. So the final answer is next question. So we are given that a bar is a unit vector. Okay, so we know that magnitude of A is 1. Now this we have to solve and find x bar, magnitude of x bar. So x bar plus a bar dot x bar minus a bar is bar square minus a bar square plus x bar dot a bar minus x bar dot a bar equal to 12. This is given. Okay, so the value of a bar square is 1. 12 plus 1, 13 root 13.